Today we're going to be multiplying 2-digit by 2-digit numbers. So our example today is 46 times 23. And we always start with our digit that is in the ones place. And we always sing our song in class, up and over, magic 0, over and up. So I'm going to start by first going up. 3 times 6 is 18. I write my 8 in the ones place and I carry my 1. Then I'm going to go over. That's my second step. 3 times 4 is 12. Add our carryover. Plus 1 is 13. And because I don't have any other digits to multiply by my 3, I'm just going to put my 13 at the bottom. Then we move on and we've done our up and over, and we have to put our magic 0. And our magic 0 goes in the ones place because it's holding our place, because we no longer have any ones. I can cross out the ones place. I'm done with that. And we're multiplying by 2, which is in the tens place, and every 10 must have a 0. I can also cross off my carryover because I'm done with that. My next step is I'm going to go over first. So I'm doing 2 times 6 is 12. I write down my 2, carry my 1, and then we go up. 2 times 4 is 8, plus 1 is 9. And last, we just add up the two numbers. 8 plus 0 is 8, 3 plus 2 is 5, 1 plus 9 is 10. So our product of 46 times 23 should be 1058. I have taught the kids how to check their multiplication problems using digital root. And all digital root is we're taking a number and we keep adding the digits together until we get it down to one single digit. So for instance, if I want to find the digital root of 46, I simply add my 4 plus my 6 and I get 10. Then I ask myself, is 10 a digital root? Is it a single digit? No, it is not. So I continue adding, and I'm going to add the 1 plus the 0. 1 plus 0 is 1. I do the same thing for 23. 2 plus 3 equals 5. I ask myself, is that a single digit? And yes, it is. So I do not have to do anything else to find the digital root of that number. Now, the step that most students get stuck on is that they forget that they have to take these two numbers and they have to multiply them together. And 1 times 5 is 5. So the digital root of my two factors multiplied together is 5. So I check myself by checking to see if the digital root of my answer equals 5. So let's start. We add together 1 plus 0 is 1, plus 5 is 6, plus 8 is 14. Is 14 a digital root? Well, no, it's not, so I have to keep adding, and I add 1 plus 4 equals 5. So if my two digital roots come out to equal the same amount, then my answer should be correct. Now, the one thing that might happen that would cause your digital root to still come out correctly, but for you not to have a correct answer, is if you were to put your digits down in the wrong place. So, if you were to, for instance, sorry about all the barking dogs, please ignore. Okay, so as I was saying, the way that the digital root could turn out to still be 5, but your answer would be wrong, is if you were to put the numbers in the incorrect order. So if you were to incorrectly mix up your digits and write it down as 1085, then if you were to add them up, 1 plus 0 is still 1, 1 plus 8 is 9, and 9 plus 1 is 14, and you would end up with the same digital root, but you would have the wrong answer. So again, the steps are very important for finding the correct product, but this is just a way that we can check to make sure that we are probably going to be correct.